Hello guys, welcome to PerspiScience. In this video we'll be checking reflection, refraction, critical angle and the total internal reflection. First, what is reflection? Reflection is simply the bouncing back of a light ray in the same medium. For example, if we have a plane mirror and a light ray striking that mirror, it will simply reflect back. So, the ray which strikes the mirror, we call it the incident ray. And the ray that reflects back, we call it the reflected ray. So that is reflection in simply. Then we have what we call the law of reflection. The law of reflection says that the angle of incident must be equal to the angle of reflection. But how do we measure those angles? In order to measure the angle of incident and the angle of reflection, you must have normal. Then we draw normal with dotted line perpendicular to the surface. Then to measure the angle of incident, you can measure it from your normal up to the incident ray. And to measure the angle of reflection, you can measure it from the normal up to the reflected ray. So here theta 1 is equal to theta 2 according to the law of reflection. So let's move to refraction. What is refraction? Refraction is simply the bending of a light ray as it moves from one medium to another medium due to the changes in speed. For example, let's say we have two medium, water medium and air medium, with air having a refractive index equal to 1 and water having a refractive index equal to 1,33. And we say there is a light source inside the water. It might be a swimming pool light emitting a light ray into the water-air boundary at a certain angle measured from the normal. It is said that the light ray will bend as it moves from the water medium to the air medium, reason being change in the speed of the light ray. Since from water to air, the light ray will gain speed. Yes, perspicacious, we understand that moving from one medium to another medium, a light ray will bend. But will it bend towards or away the normal? If a light ray moves from a denser medium to a less denser medium, the light ray will move away from the normal. But if a light ray moves from a less denser medium to a more denser medium, the light ray will move towards the normal. So in this scenario, the incident angle is less than the refracted angle. Note this, if the incident angle is increased, the refracted angle will also increase. Let's move to critical angle. What is critical angle? Critical angle is the angle of incidence in the denser medium that makes the angle of refraction in the less denser medium to be equals to 90. But how do we get that angle of incidence that will make the angle of refraction equal to 90? We simply use the Snell's law, which is written as n1 sine theta 1 equal to n2 sine theta 2, where n1 represents the refractive index of medium 1, theta 1 represents the angle of incidence, and n2 represents the refractive index of medium 2, and theta 2 is the angle of refraction. So to calculate the critical angle from water into the air, we will simply substitute our N1 to be 1,33, which is the index of refraction for water, and our theta 1 will be equal to the critical angle, since we said that a critical angle, it is the incident angle that will make the refractive angle equal to 90 degrees. So our N2, it will be our index of refractive for air, which is 1. Then sine theta. Our theta 2 here, it will be the 90 degrees. So you just solve for critical angle. So sine 90, it makes 1. So we divide both sides with 1.33 to give us sine theta c equal to 1 all over 33. You take sine to the other side, or you just do the inverse of sine, which at the end will give you the critical angle to be 48,75. But in a simpler way, the critical angle is equal to the inverse of sine into n2 divided by n1. Let's move to total internal reflection. So total internal reflection, it is when a light ray is reflected back into a denser medium when it strikes the boundary with a less dense medium at an angle of incident greater than the critical angle. For example, if having that same scenario with air having a refractive index equal to 1 and the water having a refractive index equal to 1,33 and a light source at the bottom of the water which emit a light ray at a certain angle measured from the normal, it is said that if that angle of incident it is greater than the critical angle, the light ray will bounce back into the denser medium, or it will just reflect back into the denser medium. Remember, on refraction we said that increase in the incident angle will also cause the refracted angle to increase. If the incident angle is equal to the critical angle, the refracted ray will be horizontally with the surface. Since a critical angle makes the refracted ray to have a 90 degrees angle in between with the normal. So in short, if the incident angle is less than the critical angle, it is a refraction. And again, if the incident angle is equal to the critical angle, the refracted ray will be horizontal. And if the incident angle is greater than the critical angle, total internal reflection will occur. Thanks for watching PerspiScience. If this video helped you, please like and subscribe.